Dear students, good morning. Um, Today, uh, exam is very near, so it is really important to solve this question paper. So today we will solve February March 2026 AS level variant 22. So we will start now. First question: define force. It's a very simple question. We know force is the rate of change of momentum. Clear? Use the definition to show that SI base unit of force is kg meter per second square. Use the definition. We need to use that definition. So the definition is F equals to del P by del T equals to del P means MB. MB means mass into velocity divided by time equals to kg into meter per second divided by second equals to kg meter per second square. Okay, it's done. Student is investigating the relationship between the force applied to the piston of a syringe and velocity of the fluid um, exciting exiting the syringe. Okay, fluid oats. Okay, fluid exiting the syringe. The student wishes to use the equation B equals to Fk divided by Ma, where B is the velocity of the fluid exiting the syringe, F is the force, K is the constant SI unit, base unit, meter square per second, M is the mass of the fluid, and A is the cross sectional area of the piston. By considering SI base unit, the equation state and explain whether the equation is homogeneous. What is the condition for homogeneous equation? The condition of homogeneous equation is that the either side of the equation, the base unit will remain same. That is the condition. So we can write here left hand side, the base unit left hand side, we know that V is the velocity, SI unit meter per second. Now we will check in right hand side the unit is meter per second or not. So right hand side, what are the values? Fk divided by Ma, where F is the force means Ma means kg into meter per second square into k is a constant, meter square per second, small m is the mass which means kg into a cross sectional area means meter square. So we can cut kg, m square, it forms m s to the power minus 3. So left hand side meter per second, right hand side meter per second cube, they are not same. So what we need to write here? Since the SI base units on both sides of the equation are different, the equation is not homogeneous. Okay, first question done. The second one, state the principle of conservation of momentum. So, what are the conditions for the principle of conservation of momentum? Momentum says that if no external force act on a system, the before collision momentum is equal to the after collision momentum, right? So, what we can write here, if no external forces acts on a system, the total momentum of a system remains constant or is conserved. Okay. B. A stationary boat of mass 160 kg floats on water. This is 160 kg. 160 kg. The mast of the boat is vertical. Okay, it is vertical. A sack of mass 23 kg. This is 23 kg. You can write the values beside the diagram, on the diagram, so that it will be easy for you to calculate the other full question maths. Immediately before colliding with the mast of the boat, the sack is traveling horizontally with the speed of 3.4 meter per second. Okay, 3.4 meter per second. The sack collides with the mast and remains in contact with it without rebounding. Assuming the air resistive force act on the boat during the collision are negligible, calculate the horizontal speed of the sack and the boat immediately after collision. So what is happening here? If two objects, one is rest, the boat is at rest, the sack is coming here, it's coming here. After the collision, they collide, they combined, and this is the final momentum. So here, if I draw it here, if I write it here, suppose this is sack, this is rest, this is the boat, and after collision, they stick together and forms one object. So the equation is m1u1 plus, definitely m2u2 is 0. Okay, we can write here m2u2 equals to m1 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 plus m2 into b. So we can write here, suppose if the boat is m1u1, okay, m1u1 is 0, it was stationary, plus 23 into 3.4, because it is 23 and 3.4, and then equal to 23 plus 23 is the mass, and 160, 23 plus 160 into b. If we calculate v, it comes 0.427. If you use the calculator, you are getting these values. So here, see one important thing, it is 3.4 is two significant figure, and then 160 is two significant figure, 23 kg is two significant figure. So answer must be two significant figure, and the answer will be 0.43 meter per second. The total kinetic energy, now it's about the kinetic energy, the total kinetic energy of the sack and the boat immediately before the collision is U1, before collision is U1, and then total kinetic energy of the sack and the boat immediately after collision is E2. Determine the ratio of U1 and E2. Okay, U1 and E2. What is U1? E2 divided by U1. E2 is the total kinetic energy sec and the boat immediately after the collision. So we can combine kinetic energy half mba square. So half into both mass will combine here, 160 plus 23, half m into, if the velocity is combined mass velocity, we get 0.43. It's 0.43 square, half mba square, divided by, before collision is e1, before collision only the sac is moving, the board was rest. So uh, the seg has only that kinetic energy. So half into mass 23 into the velocity was 3.4. Okay, the velocity was here 3.4 square. Now again, if we use calculator here, we are getting the values 16.92 and 132.94, and the final answer is 0.1 to 7, means the ratio is definitely two significant figure, 0.13. See, ratio means only decimal values, not more than that. Okay, state and explain whether the collision between the sac and the boat is elastic or inelastic. See one thing here, what are the conditions for elastic collision and inelastic collision? If before collision kinetic energy is conserved, the collision is elastic. If before collision kinetic energy and after collision kinetic energy they are equal, so the collision is elastic. If before collision kinetic energy is not equal to the after collision kinetic energy, the collision is inelastic. So here we already got the values. See how before collision kinetic energy is 132.94. After collision kinetic energy it becomes 16.92. So it's, they are not equal, they are not same. So the collision is inelastic collision. So what we will write? State. First of all, we need to write here inelastic collision. Inelastic collision. Because before collision kinetic energy, before collision kinetic energy is not equal, to the after collision kinetic energy. I think you are clear about it. After a short time, the boat in 2B is at rest. Show that the upthrust acting on the boat with the sac is 1800 Newton. Okay, upthrust is the upward force here that acts due to the upward pressure of water here. It is at rest, means weight is acting downward, upthrust is acting upward. So they are in equilibrium, means if we can calculate weight, that is equal to the upthrust. So let's calculate the weight of the object. So we can write here at rest, for more explanation, at rest and floating, upthrust is equal to weight. So upthrust, so upthrust equals to, the total mass is 160 plus 23 into 9.81, and it's 1795, approximately equal to 1800 Newton. Good. The board displaces water with a volume of 1.8 into 10 to the power 5 centimeter cube. Calculate the density of water. Give your answer is three significant figure. Okay, 3SF. Upthrust is here. Upthrust is here. So, what is the equation of upthrust? Upthrust F equals to rho Bg. So, we need to calculate the density. So, density equals to rho equals to F divided by Vg. Upthrust is 1800. Volume is given 1.80 into 10 to the power 5 into, see here, it is in centimeter cube and there kg per meter cube. So that is why we need to concentrate must. What is the unit is given on the question paper. We need to convert them first. So centimeter cube to meter cube. Centimeter to meter is 10 to the power minus 2. Square 10 to the power minus 4. Cube 10 to the power minus 6. Okay, so into 10 to the power minus 6 into G is 9.81. 9.81. The answer is given. If you calculate, it will be 1019. So you need to give it in three significant figure, 3SF. So it will be 1.02 into 10 to the power 3 kg per meter cube. That's great. It's question number 3. Let's do it. Question number 3. Here, a roller coaster carriage, a mass 280 kg, travels over a raised section of track as illustrated in figure 3.1. It is 280 kg. Okay. At position X, the carriage has a kinetic energy 16.1 kilojoule. Okay, here the EK equals to 16.1 kilojoule. At position Y, it has kinetic energy 1.3 kilojoule. Here, 1.3 kilojoule. The length of the track between X and Y is 23 meter. It's a straight distance here to here is 23 meter. In moving from X to Y, the carriage does 5.1 kilojoule of work against resistive force. Okay, this is also loss of energy. Energy losses. Calculate the average resistive force acting on the carriage between X and average resistive force. So average work done is given. This is very simple. Very simple. We know that W equals to Fs. So F equals to W divided by S. For resistive force, work is given 5.1 into 10 to the power 3 divided by distance moved is 23. Use your calculator and we are getting 221.7, which is, see how many significant figures are here. 1.3, 23, two significant figure, 1.3, two significant figure, 5.1, two significant figure, one significant figure as well, 3 as well. So least one is two significant figure. I really need to write the answer in two significant figure. Okay, so it will be 220 Newton resistive force. Okay, calculate the change in height between X to Y. Change in height. That is due to the gravitational potential energy. I have kinetic energy. Total kinetic energy is 16.1. I'm getting 1.3 kilojoule. And at the middle, the lost energy is 5.1 due to work done. That I need to subtract. From initial kinetic energy, I need to subtract the total work done. And I have last 1.3 kilojoule energy here. So if I subtract this 5.1 kilojoule energy and 1.3 kilojoule 1.3 kilojoule energy. The rest is the potential energy, that equals to mgh. So we can write here mgh equals to, my initial kinetic energy was 16.1 into 10 to the power 3 minus the that one was kinetic energy, remain kinetic energy 1.3 into 10 to the power 3 plus my work done lost energy 5.1 into 10 to the power 3. So m is here, the mass, the value of, okay, we need to calculate the height, del h. So h equals to this one, this one 16.1 into 10 to the power 3 minus 1.3. Okay, I have done the calculation here. So h equals to, the whole answer is, this is 9700 divided by m. M is mass is given 280. Okay, this is 280 into 9.81. I got the answer here, 3.53. Here also as well, maximum there are two significant figure. The answer will be also in two significant figure. It will be 3.5 meters. Next thing, the carriage travels further along the track to point Z. Okay, from Y to point Z is here. Okay, Y to Z. State and explain whether the speed of the carriage at Z will be greater than, less than, or same as the speed of the carriage X. Um, what will be the speed? Suppose it's gaining height and it's again going down. Speed supposed to be constant, but here some work is done due to resistive force, means some energy is lost. So I'm not getting the same speed, though the same height is moving, going back again. So due to resistive force, I'm not getting the same speed. So what we can write here, speed at Z, speed at Z will be less, than the speed, at X, because some energy has been dissipated. Some energy has been dissipated by resistive force. Through X and Z. Though X and Z are at the same height. Okay. It's about next question. A uniform square picture is attached to a wire and hangs in equilibrium from a pin at point P, shown in figure 4.1. Okay. The picture has a weight 19 Newton. Yes, it's acting downward. Its center of gravity directly below P. Okay, center of gravity is below P. Okay. The top side of the picture is horizontal. The wire forms an angle theta with horizontal. the tension T in the wire is 13 Newton. Define moment of a force about a point. About a point. Okay, moment of a force. What is moment? We know that moment is the product of force and perpendicular distance from that point. Okay, we will write it here. Moment of a force. Moment of a force at a point, because they are asking here at a point. At a point is the product of force and perpendicular distance perpendicular distance from the from that point from that point. Okay, from that point. Okay, explain why the moment of the weight about p is zero. About p, moment of the weight. See, p is the pivot and weight is just under the pivot. So for turning effect of force, we need a perpendicular distance from where the force will apply it. If the force is on the pivot, there will be no moment. So here P is just on the pivot. So we will write the perpendicular distance, the perpendicular distance from P is 0. So the moment of the weight, so the moment of the weight about P is 0. Calculate theta. Calculate theta. Calculate theta. Okay. 19 Newton is acting upward, downward, and here the vertical component of T is acting upward. They are balancing each other. T is 13 Newton. So this component, this vertical component will be T sine theta here, which means 13 sine theta. Here it will be also T sine theta, means 13 sine theta. So 13 sine theta here, which is balancing the weight, which is 19 Newton. So what we can write here, 2 into 13 sine theta is equal to 19. So theta equals to sine inverse 19 divided by 26. The result is 46.9 degree, which is, we can write here, 47 degree. Okay. The weight has diameter. The wire has diameter 0.88. So radius will be, R will be 0.4 into 10 to the power minus 3 meter. And made a metal of Young modulus 9.3 eto, the wire obey Hooke's law. Calculate the strain. So what is the equation of strain? We know that E equals to stressed Young modulus equals to stress divided by strain. Stress divided by stress is the F by A in divided by strain. Strain, we can write it here. Strain is this one is the strain. So if we calculate a strain equals to F divided by A into E. F is the force. Force means F is the force. A strain of the wire. The wire is giving the wire 13 Newton. So F is the 13 Newton. 13. Area means I need to calculate the pi r square. It's pi into r 0.4 into 10 to the power minus 3 pi r square into, we have Young modulus, the value is given 9.3, 9.3 into 10 to the power 10, and the answer is 2.78 into 10 to the power minus 4. If you use your own calculator, you are getting the values, but we need to write the answer in two significant figure, because 0.80 is two significant figure, 9.3 is two significant figure. The answer definitely in two significant figure. It will be 2.8 into 10 to the power minus 4. There's no unit, okay, because it is strain is a ratio of extension to original length. The bottom side of the picture shown in figure 4.1 is 1.6 meter above the ground. Okay, 1.6 meter. The P breaks and the picture falls vertically downwards. Resistive force acting on the picture are negligible. Calculate the time taken for the bottom side of the picture to hit the ground. See here, air resistive force acting negligible means it will be constant accelerated motion. What we know about the constant accelerated motion, we have three equations: b equals to u plus at, s equals to ut plus half at square, and b square equals to u square plus 2as. Distance is given here 1.6 meter. Time is not given. So here the last equation we will use, which is b square equals to u square plus 2as. So if I use here, or no, we need to calculate the time. We need to calculate the time. So definitely the equation will be s equals to ut plus half at square. So use here s equals to ut plus half at square. S equals to ut plus half at square. We need to calculate calculate time. So ut is 0. Ut is 0. So t equals to root 2s divided by a equals to root 2 into distance is 1.6 divided by definitely no resistive force means constant acceleration is 9.81 gravity. The answer is 0.57. Okay, the time is 0.57 second. Figure 4.2 sketch the variation of the speed of the picture with the distance fallen from its initial position. Distance and speed. Distance and speed. Okay, what is the equation? B square equals to u square plus 2as. If u is 0, acceleration and 2 are constant, we can write b square proportional to s, which means s proportional to b square. What we can write? B if 2 square equals to 4, 3 square equals to 9, 4 square equals to 16. So if it is gradually increasing, speed is increasing gradually, distance will increase more. Distance will increase more. It will not be a straight line. It will be a speed. Distance will increase more. Means the graph will be like that. Okay, but if 1.6 is given, I need a speed point here. What will be the speed at that point? So we can use b square equals to u square plus 2as. Distance is 1.6. So b equals to u is 0, root over 2 into 9.81 into distance is 1.6. We are getting here 5.6. 5.6. So if it is 5.6, 5.6, and I'm getting here a point. Getting here a point. If it is this point, if it is this point, the line will pass through like that. Okay, this is the answer for this question. Nice. The next question, question number 5. It's from the wave chapter. For a progressive wave, state what is meant by period. We know about it. Period. Period is the time taken for one complete oscillation, right? Period. Period is the time taken for one one complete one complete oscillation. And then it's about the amplitude. Amplitude, we know that amplitude is the maximum displacement from rest position. We can write here amplitude, right? Amplitude is the maximum displacement of a particle from its rest position. A stressed string is fixed at both ends and made to vibrate with a frequency 25 hertz. Okay. Stationary wave is formed on the string. Stationary wave is formed on the string. The distance between the fixed end of the string is 0.96 meters. Stationary wave formed on the string. So here I can reshape it. This is the stationary wave. Okay. Figure 5.1 shows the spring at one instant. On figure 5.1, draw the cross at the position of antinode. Antinode is the area where the amplitude is maximum. So we can make a cross here, here, or here, anywhere. Show that the speed of the progressive wave of the string is 16 meter per second. Speed. What is the equation of speed? B equals to f lambda. F is the frequency is given here. See, frequency is given. Frequency is 25 into lambda. Here it is 0.96 meter, but it is 1.5 wave. 1.5 wave. So lambda is 0.96 divided by 1.5 wave. 1.5 wave equals to 16, and there equals to 16 meter per second. Two significant figure. Okay. The frequency of the vibration is increased to 30 hertz. The speed of the wave on the string does not change. Speed does not change, just frequency increased. State and explain whether the stationary wave will form. You need to understand a concept here. Suppose, let me explain this. Suppose this is a stationary wave and this is the length. The length is 0.96 meter. How stationary wave form will form here? It may be the first stationary for wave will form here, like that. If I draw for the second one, for the same here, the stationary wave, it may be a whole wave. Second wave will be this one. This one. The third one will be, that is here. All are 0.96 meter. Third one, 3. 1, 2, 3. Okay. And then it will be, okay, here, and then this one, and then this one here. Or two complete wave, means 1, 2, 3. Two complete waves. This one here, it's supposed to be like that. I'm doing it faster. So what about the frequency here? We got 16 meter per second speed. So I can easily find frequency. I can easily find frequency here. F equals to v by lambda. The first one is velocity is 16 divided by lambda here. If it is half, so lambda is 0.96, 0.96 into 2. The first one 1.92, 1.92 equals to the first frequency 16 divided by 0.92. 16 divided by 1.92 is 8.3, 8.3 hertz. And then for this one, 16 divided by 0.96 is 16 divided by 0.96, it will be 16.7, 16.7 hertz. The third one will be here 16 divided by here 1.5 wavelength we got here 0.96 divided by 0.96 divided by 1.5, it's 1.5 wave is 0.64, 0.64 equals to 16 divided by 0.64, it's 25, 25 hertz. And then the last one is 16 divided by here 2 wave. 2 wave means wavelength is 0.96 divided by 2, we are getting here 0.48, 0.48 equals to 16 divided by 0.48. The answer is 33.3, 33.3 hertz, 33.3 hertz. See, uh, for the first one, if it is 25, there is a stationary wave 25 hertz, stationary wave will form. So 25 hertz, we got 25 hertz. The first for this 0.96 length, and the speed is constant 16 meter per second. The first stationary wave will form when the frequency is 8.3. The second one 16.7. The third one 25 hertz, and the fourth one 33.3 hertz, not 30 hertz. Okay. Uh, so what we can write here? State and explain. We can write here that for 30 hertz, lambda equals to v by f equals to 16 divided by 30 equals to 0.53 meter. So no stationary wave will form because the length 0.96 meter is not exact whole number of half wavelengths. The same thing you can write here as well in terms of frequency. I wrote here in terms of wavelength. I calculated here in terms of frequency. You can write in terms of frequency as well. So for the condition is that one, if the frequency is 33.3 hertz, then a stationary wave will form. So after 25, it will be 33.3, not 30 hertz. C. A beam of light wavelength 4.5 meter is incident normally on a diffraction grating with 6.7 into 10 to the 5 line per meter, 6.7 line. So if we calculate D equals to 1 by 6.7 into 10 to the power 5, 1 by 6.7 per meter, 1 divided by 6.7 into 10 to the power 5. 1 by 6.7 into 10 to the power 5 is 1.49 into 10 to the power minus 6 the meter. This is D. Okay. The light passes through the grating and form a pattern of bright spot on the screen that is parallel on the grating. Okay. Central bright fringe, bright spot. The angle formed at the diffraction grating between the central bright spot and the bright spot at position X. Okay, this is also a bright spot at 37 degree. Okay. Calculate the order n of the bright spot at formed at X n. What is the equation for the diffraction grating? We know about it. D sine theta equals to n lambda. We need to calculate n. N equals to d sine theta. What we calculate D? 1.49 into 10 to the minus 6. 1.49 into 10 to the power minus 1.49 into 10 to the minus 6. Okay. Into sine 37 divided by lambda. What is wavelength? Wavelength 4.5 into 10 to the power minus 7. 4.5 into 10 to the power minus 7. What we got here is 1.99. Here, it is a very important thing. That is a diffraction grating. N equals to 0, the first order. N equals to 1. Secondly, N equals to 2. Suppose 1.99. 1.99 is here. We cannot see second bright spot because it is 1.99 is here angle. So if this is suppose 2.1, we can write 2. If 1.8, we can need to write 1. It's a whole number, less number, always the less one, because if it is n equals to 3, n equals to 3 is here, and we got the answer n equals to 2.8, we need to write 2. So this is very important thing, because we did not go there. N equals to 3 we did not see. So here we got n equals to 1.99, it will be the less one, so it will be n equals to 1, less 1. Diffraction grating is the diffraction grating is replaced by the grating with fewer line per meter. Fewer line means 1 by, if d decreases, if line with decreases means d will increase. D increases. Okay. If line number decreases, per meter decreases. State whether the distance between the adjacent bright spot on the screen increases, decreases, or same. We know that d sine theta equals to n lambda. So if d increases, n will increase. N will increase means before we got if n equals to 5. Now for the same length, for the same distance, we are getting n equals to 6. So line width decrease, whether the distance between adjacent bright light spot, they are decreasing, because in place of 5 now we are getting 6 line. 6 line is the distance is equal, so they are coming closer. So state whether the distance, just they are asking for the state, so we can write here decreases. decreases. Um, for the explanation, you can write as well. If D increases, D increases, N will increase, N will increase. So lines will be closer. Clear? I think you are clear about it. Now it's about question number 6. State what is meant by electric current. We know about it. Current is the current is the rate of flow of charge. Okay. A cell has EMF 1.50 volt, internal resistance 0.75. On figure 6.1, draw the variation with the terminal potential difference with the current for the cell in the cell for current between 0 ampere to 1.6 ampere. 0 ampere. 0 ampere means the switch is open, no current is passing. So EMF will be equal to the PD, terminal PD. Okay. So what is terminal PD? EMF 1.50. So we are getting terminal PD here 1.5. And then calculate the terminal PD when EMF when the current is 1.6. First of all, calculate the lost volt. V equals to IR. So I is 1.6 into R is 0.75, and we are getting 1.2 volt, which is lost volt. Lost volt. 1.2 volt is the red volt. So what is the terminal PD then? Terminal PD is 1.50 minus 1.2 equals to 0.3 volt. So when the current is 1.6, 0.3 volt is the terminal PD. 1, 2, 3, 3 is here. 3 is here. Now, definitely they are directly proportional, current and voltage, because resistances are constant. According to Ohm's law, what we can write? Current is directly proportional to voltage. So here as well, it will increase linearly. So we can write a straight line here. Yes, I got the answer. It will be from here, straight line, from this point to this point. See, a metal wire X has length 6.8 meter, cross sectional area 2.0 into 10 to the minus 7 meter square. Resistance of the wire, metal wire is here. This is the circuit connection. The wire connected to the circuit containing the cell, fixed resistor, resistance R. Okay, everything is given. The current in the cell is 1.8. Okay, 1.8. Calculate the resistivity of the metal wire. Resistivity. We know the equation of resistance, law of resistance, R equals to rho L by A. So rho equals to R A by L. Resistance is given 0.82 into area. Yes, cross section area 2.0 into 10 to the minus 7. 2.0 into 10 to the power minus 7 divided by the length of the wire. Length of the wire is 6.8 meters. 6.8. 6.8. We are getting the answer 2.4 into 10 to the power minus 8 ohm meter. Okay. 1.8, too significant, too significant. Yes, answer will be too significant figure. 2.4 into 10 to the power minus 8. Calculate R. R means this one. I need to find this one. I need to find this resistance. So R equals to V by I. Voltage. I need to find the voltage here. I need to find the voltage here. And I need to find the current here. Current here as well. So what can I do? I can find the voltage of lost volt, and then I can subtract it from the EMF so that I can calculate the voltage across R. Okay, let's do it. First of all, lost volt equals to 1.8 into 10 to the 1.8 into 0.75 resistance. B equals to IR, 1.35 volt. So BR, voltage across R, will be, we can subtract from the EMF, 1.50 minus 1.35 equals to 0.15 volt. Now I can find the current here across the wire. Current across the wire, I W I equals to B by R. Voltage, definitely I got it here, 0.15, because they are connected parallelly. The voltage remains same, and the resistance and the current is here, I equals to B by R, 0.15 divided by the resistance is 0.82, equals to 0.183 ampere. Now I got everything, so I can calculate R equals to B by I. Voltage across this resistance is 0.15, and current I can subtract from the total current, 1.8 minus 0.183 equals to 0.0928 ohm. So the resistance is 0.093, because see, they are all two significant figure. Answer will be also in two significant figure. Calculate the power dissipated in the internal resistance of the cell. Listen, if the question is the dissipation of power, it will be P equals to I square R. Sometimes we tell that it is I square R loss, power loss. So you calculate the power dissipation, P equals to I square R. So what is the current across the internal resistance? The total current, 1.8 square into the resistance of total resistance, 0.75. We got the answer, 2.43. Definitely in two significant figure, the answer will be 2.4 watt. Finally, the last question. Let's do it. Uh, Describe the structure of a nuclear atom. Structure of nuclear atom means inside proton, neutron, and outer shell electron. We need to write this thing actually. So we can write uh, a nuclear atom. A nuclear atom has a very small, dense, positively charged, positively charged nucleus. Nucleus containing protons and neutrons. Electrons occupy the region around the nucleus. Around the nucleus. Okay. P and Q are radioactive nuclei. P has 94 proton, Q has 91 proton. Each nucleus decay to form a nucleus with 92 proton. State the type of radioactive decay experienced by P. Each nucleus decay to form a nucleus 92 proton. 92 proton. So P, 94 proton, 92 proton means 2 proton decreases. So if 2 proton decreases means definitely alpha decay. Alpha decay. For alpha decay, atomic number will decrease by 2, mass number will decrease by 4. Simple. So here two proton decreases. So we can write alpha decay, because it loses two protons. State the type of radioactive decay experienced by Q. See, Q 1191 proton and it 92 proton gains one proton. So definitely it's beta decay. Beta decay means atomic number plus one. Atomic number plus one. So atomic number here, atomic number is plus one. So beta decay. So next one we can write beta decay because it gains one proton. In beta decay, one neutron splits and one proton and one yeah, neutron split. In beta minus decay, there are two type of beta decay. One is beta minus decay, another one is beta plus decay. Beta minus decay is neutron decay. Beta plus decay is proton decay. So in beta minus decay, neutron splits and produces one proton and one electron. That is beta decay. So one proton increases. Particle X has a ratio. Particle X has a ratio of charge to mass equal to 1.76 into 10 to the power 11. Identify the particle X. Charge to mass ratio particle. Suppose we have particle, charge, proton, we have electron. Suppose alpha decay, alpha. If the particle is alpha, we can find the for alpha we can find the charge to mass ratio. Alpha particle 2 proton, which means 2 into 1.6 into 10 to the power minus 19 divided by mass 4. Okay, atomic number 4. 4 into 1.66 into 10 to the power minus 19, it forms 4.8 into 10 to the power 7. The answer is not matching. We can find the charge to mass ratio of beta particle. See here, deca is beta particle. For beta particle means electron. What is the charge of electron? Minus 1.6 into 10 to the power minus 19 divided by mass of the electron, 9.11 into 10 to the power minus 31 kg. It is minus 1.76 into 10 to the power 11. See, yes, this is the value, but it is here, this is plus, we got minus. So actually this is beta plus, which means it is um, positron. Yes, X is positron, or you can write here beta plus decay. End of the question paper. Thank you. I think it will be helpful for you, though we did not get the mark scheme yet. Bye bye. See you soon.